Hello, everyone. I'm Nick Schultz. You probably got a few emails from me leading up to this event. Today we have Terry Becker on the topic of is your electrical safety program compliant? Throughout the broadcast here, you guys can submit questions to the chat. We will address those all at the end. You'll also notice there is a handout here. This is a electrical safety expert network consulting services brochure. It's offered by Grace and Terry. And then a few other notes. This webinar will be made available on demand at a later time, and the presentation slides will also be made available. The certificate of your attendance will be emailed out 1 hour after the broadcast concludes. So with that, I will let Terry take it away.
Thanks, Nick, and thank you everyone for joining us today in this webinar. Is your electrical safety program compliant? And I want to thank Nick and Grace Technologies for sponsoring this webinar and allowing me to spend some time with you this morning. So if you don't know me, again, I'm an electrical engineer based out of Calgary, Alberta, Canada, 31 years experience. I've devoted 15 years of my career to electrical safety, starting back with my oil and gas senior staff electrical engineering job with Encounter Corporation in Calgary. Since then, I have become a founding member. I'm the first past vice chair of the Z462 Workplace Electrical Safety Standard Tech Committee, which is the Canadian equivalent of NFPA 70E. I'm also the working group leader for Clause 4.1 and the annexes. I'm also a founding and voting member of CSA Z463 Maintenance of Electrical System Standards. That's again a new standard in Canada that was developed since 2013. It's the equivalent of NFPA 70B. I'm also a voting member on the IEEE 1584 Guide for Performing Arc Flash Hazard Calculations, and also have over the years been a keynote speaker and presenter at conferences and workshops in Canada, the US, Australia, and India. And I'm the founder of my first engineering consulting company, ESPS Electrical Safety Program Solutions, and now my new company, TW Becker Electrical Safety Consulting, and a pioneer and innovator in electrical safety consulting, online arc flash and shock training, external electrical safety auditing, and developing and helping companies implement electrical safety programs. So just a standard disclaimer, I'm not going to read the whole disclaimer to you, but again, I'm disclaiming that, again, the information I'm presenting you today is my personal interpretation of standards and recommendations. If you do want official interpretation of the standards that I mentioned today, then contact those relevant organizations, NFPA, CSA, IEEE, as well as some of the material presented in this PowerPoint is copyright to my company and is not allowed to be copied or used without permission. So is your electrical safety program compliant? That's a really loaded question, and I've only got an hour of your time today to do that some justice, and it's going to be difficult. And so I will do my best to give you, again, a high-level framework and guidance on this topic. One of the first things I wanted to do is I'm just going to ask Nick to run some poll questions. So this will just sort of give you an idea of where we're going to go in the webinar. But Nick, can you run those poll questions? And so if you just answer the questions and then we can look at the quick results. So does your company have an electrical safety program? And we'll give you a, well, I don't know, we can try and get as many people in as we can here, but we'll have to cut this off eventually as well. So Nick, I'll just get you to watch the responses and decide when to stop the question and move to the next one.
All right, so we have 62% yes. I don't want to close it out. I'm trying to see how we can display that. 63% are saying yes, 12% are saying no, and then 24%
would be NA because they're probably not employers, right? So it depends on the mix of attendees if you would have an electrical safety program or not. If you're an associated, supporting, industry or to this topic, then your company wouldn't necessarily have an electrical safety program.
All right. There you can see the results.
There we go. Yeah, that's pretty good. Okay, next question. if you have an electrical safety program, do you believe it is compliant? Now, this one's a loaded question because I think people that have a program think it is compliant, but they haven't even audited it. So they, you haven't checked it. Again, you haven't tested its requirements. So we'll see what we get for responses here. Because I find that when people, oh, Terry, we got a program, it's compliant, no problems. And then if I do look at that program, it's not compliant. And when I talk about compliance, we'll discuss that in the webinar. So let's see what we get as a response for this. For those that said they had an electrical safety program, how many believe it's compliant?
So you can see the results.
46%. So half believe it's compliant. Okay, next question. If you have an ASP, have you audited it? So if you have an electrical safety program, have you audited that program? Internal audit, external audit. Because what I find is most companies that have an electrical safety program haven't audited it. There's no internal electrical safety audit requirement identified in the framework or table of contents. And if you don't audit an occupational health and safety management system, you have no idea if it's actually performing to deliver the results that you want it to achieve. So we'll see what happens here. So we had 64% say they have a program, 46% believe it's compliant, and then let's see how many people have audited it. How many companies have audited the program if they have one? 33%, right? So that's I'd say consistent. Next question. And then again, 33% say they have audited, but what comprised that audit? Internal or external? Have you provided arc flash and shock training to your qualified persons? So again, across the attendees that have employees working for them or bring in contractors, have you provided arc flash and shock training for employees or validated that the qualified persons for your contractors, that those qualified persons have had arc flash and shock training? This should be a higher percentage. %59%, right? Okay, next question, Nick. Have you procured arc flash and shock BP tools and equipment and provided to qualified persons? Again, this should be a higher percentage as well. And there's a reason why, and I'll talk about that in the webinar. It's great news if you have employees and you've procured arc flash and shock BP, but the key will be, are they even wearing it, right? So after you've procured it. That's another problem that comes up when I work with companies and they say they have compliant programs and they provided training and they bought PPE and they don't even have a method to confirm that the qualified persons are wearing it. So 64% have procured arc flash and shock PPE. Next question. Have you completed arc flash hazard incident analysis studies for your facilities? Again, you'd have to be the employer, the owner of the facility, right? So again, if you're not, then the answer would be NA here. So those of you attending that are the employer that own the facility, have you had a study completed for your facility? This should be a higher percentage as well. %46%, okay. Right, next question. Do you believe that the installed arc flash and shock equipment labels are compliant from your study? So compliant arc flash and shock labels, and I'm using the word compliant a lot. Again, that's the gist of our presentation is compliant electrical safety program, but compliant arc flash and shock training, compliant arc flash hazard incident analysis study, compliant arc flash and shock equipment labels. It's an important word that employers that are, implementing these risk control methods need to be able to, say, hey, those are. But then how do you identify that they are, right? So let's see how many people think their labels installed are compliant, because in the last 6 months, I've been on client sites now these days with COVID lifting in both US and in Canada, and the labels installed from the studies are not compliant. And I think that's the last question, isn't it, Nick? Is there another question?
There is one more.
One more. All right. Can you validate the residual risk level to qualified persons before they performed energized electrical work? Now, this one's a loaded question, because if you have an electrical safety program and it's not compliant, you might not have a qualitative risk assessment requirement. Therefore, you haven't completed as the employer risk assessments, but at that outcome of that risk assessment is identifying the hierarchy of risk control methods the worker needs to apply in the field. But how do you know that they're applying the controls that you expect them to apply? Right, so residual risk level, right? So that's with controls applied. The qualified person, right? They should have these controls applied, but how do you know that they've actually applied them? Can you validate that? Yes or no? Prove it. Can you prove it? So 28%. So that one's interesting, because there might not be a clear understanding of what I'm implying by that question. But again, I won't be able to answer all these questions today, but I'm going to stimulate thought around these poll questions. Thanks, Nick. All right, so an overview of our presentation today is some of the statements I already made. Is I don't think a lot of employers, have developed electrical safety programs. And if they do have an electrical safety program, it's not compliant. This is from my experience over the last 10 years of doing specific focused electrical safety consulting and specific electrical safety program development implementation work. So I'm hoping today we can give you some more broad answers to the questions of what a compliant electrical safety program is, identify the tools and information that you can use in reference to confirm if you have a compliant electrical safety program, or information on how to start to develop an electrical safety program. All right, so please enter questions and we can review those again at the end of the webinar. So does an employer need an electrical safety program? Well, right away the answer is yes, you do. And do you have a program, which is part of the poll questions, develop and implement? If yes, have you had it audited? It's really important that it's audited, and I find, well, I'd say almost 100% of the companies that I've come in to help, they have a program, or they say they have a program, or they have controls. None of it's been audited. None of it. The training hasn't been audited. The studies haven't been audited. The labels haven't been audited. The arc flash and shock PP tools and equipment that have been procured haven't been audited. All right, so that's a huge problem and a huge gap. Right? What framework or table of contents information should a compliant electrical safety program include in it? I'm going to provide you some information to help you hopefully understand more about what that information should be. So when I see programs, it's like, well, that's just cut and paste from 70E. That's not a non-electrical safety program. So an electrical safety program has to have a specific framework and table of contents consistent with occupational health and safety management system standards. How can an employer be successful in developing and implementing a program? I'm going to give you some high-level guidance on that as well as we move through the webinar. So the agenda is we did the poll. I'm just going to break away a little bit and talk about electric shock sequelae and sequelae first, and this new electrical injury day of recognition that we have started last week in Canada, October 6th, related to electric shock. And then we'll move into the electrical safety program review by starting with an electrical safety due diligence framework, how to develop, follow a plan, do, check, act philosophy, some common electrical safety program gaps. What do NFPA 70 and CSA Z462 tell us that you require in your electrical safety program? OSHA requirements and recommendations, Canadian provincial OH&S requirements, CORE, the certificate of recognition system. These documents from OSHA or in Canada provincial OH&S regulators, they give you advice. And if you weren't aware, I'm going to show you where you can go to get advice even from the regulator on what an occupational health and safety management system should include for content, which just bridges completely to an electrical safety program, which is an occupational health and safety management system for arc flash and shock hazards. Why prioritize a compliant electrical safety program? What I find is employers are sending workers on training, buying PPE and getting studies, and not prioritizing any time on creating documentation to manage those three things and other elements of the hierarchy of risk control methods so that you can formally more effectively manage this and ensure that you have appropriate due diligence again, and that's subjective. If you ever have to test any of this, what you've done to date, and that unfortunately would be if you have an incident, heaven forbid a fatality, that's when you'll ultimately know if you've got a compliant electrical safety program. So how to develop? Use a project execution plan. Treat it as a project. We'll talk about that. The electrical safety framework and table of contents. And then I'm just going to provide some continuing advice on managing arc flash hazard incident analysis studies and arc flash PP evolution, then a bit of a conclusion and questions at the end. So electric shock sequelae and sequelae, if you haven't heard of this yet, it's been around for a while. It just hasn't had any notoriety. So there are long-term effects of receiving multiple low voltage shocks. So the problem is most qualified persons, electrical workers, haven't reported any of their shocks. So there's no evidence, there's no proof, there's no insurance that would be offered if you have long-term sequelae. So in Canada, this has actually been studied for over a decade, as well as in the US. And I've also written some articles in the last couple of years on this, as this has become prevalent with one electrician that's come forward to me formally. His name's John Knoll, and that set this off. So I knew about sequelae and sequelae, but really no electrical workers had come forward, so I didn't really give it any attention. When John came forward and he asked for my advice and he grabbed onto it because of his personal issues with sequelae. He's a journey person electrician that's no longer in the trade because he's got sequelae, right? So some information for you, a little more research required, but the University of Chicago has the Chicago Electrical Trauma Research Institute. Google that and check it out. And then we have the Sunnybrook Health and Science Center Electrical Injury Program. Now, these are programs to work with qualified persons, specifically all electrical workers that have been unfortunately received multiple electric shocks in their career and never reported them. There's no WCB insurance claim records whatsoever. So that's a challenge, right? And we need to change the narrative. We need to get more focus on the electric shock hazard. So to do that, that's John Knoll on the right, myself on the left, is John and I put forward a paper for the IEEE Electrical Safety Workshop this year that was in Jacksonville and presented in March. So we were still in the middle of COVID, but John and I flew down there and we had people show up, and it was good to interact with people in person, and specifically this poster session. So we had a lot of people come by and talk about electric shock. And then John was talking about his story of receiving multiple shocks right from an apprentice. And so we need to get the narrative on to electric shock and away from arc flash. You're highly unlikely to have a worker ever exposed to an arc flash, but there's workers being shocked today in North America and electrocuted. There's most likely not an arc flash burn injury resulting in a fatality today at all. Potentially, maybe no arc flash burns, but I know there's multiple electric shocks happening still because we have not solved this problem yet. So there was an article written by two doctors in 2013 at Edmonton, Alberta that didn't go anywhere. It went to doctors. It didn't get into the electrical community through the electrical contractors associations that we have in each province in Canada. And on the right, there's over 30 potential sequelae. So sequela is a secondary effect of a primary hazard exposure in the workplace. So you get an electric shock, get it multiple times, and then you might have up to 30 potential physiological, neurological, and physical symptoms. So just an FYI, dig into this a little bit more for your organization. If you are a journey person electrician on this webinar today, you need to pay attention. So what we did in Canada as an outcome of John coming forward and the work that I did with him is the Electrical Contract Association of Alberta contacted the Canadian Electrical Contract Association, which is the same thing as NECA in the US. And last week, we had the first inaugural Electrical Injury Day of Recognition to focus on the electric shock hazard and electric shock sequela. So to hear more about this as this keeps going on, I'll be making sure that I keep a profile on it in my social media postings and on my website as well. Now, moving into our electrical safety program compliant discussion. This is a busy slide, but it's really the whole webinar on a page. Electrical safety due diligence framework. It starts with those OH&S regulations, whether it's provincial or territorially or federally in Canada or federally in the US. And the general duty clause, the employer needs to identify all hazards. So arc flash and electric shock should be two identified hazards. Underneath that, an occupational health and safety management system and mandatorily should be developed. And underneath that is your electrical safety program. Now I've got some snippets of websites, of some documents that I'll talk about in the webinar today, and those become sort of resources. Well, the regulations are the law, so you really have to look at those and go, okay, how do we comply with that law? And that's the due diligence piece. And then we can look to the government for some guidance. So OSHA provides some guidance on building an occupational health and safety management system. And in Canada, some of the provinces will provide guidance as well. And then we have standards for occupational health and safety management systems. On the left and right here, CSA Z45001, and on the right, ANSI Z10, right? And you can use all of this information, some recommendations from the regulator and these other standards to build a compliant electrical safety program or audit an electrical safety program that you have to make sure it is compliant. And ultimately on the bottom right, we're also using obviously 70E and Z462 as these toolboxes. These are standards, they're not adopted into law, they're voluntarily applied. They provide guidance on what content should also be an electrical safety program, but it's not complete. And they do identify that it's mandatory that your company has an electrical safety program. Article 110 in 70E and clause 4.1, I think, are neglected in training and neglected in being communicated to the employer, management, supervision, safety professionals. So again, these documents say you mandatorily need a program. They give you some high-level guidance, and then you have to dig a little deeper. And then over on the left, Plan, Do, Check, Act. That's a philosophy, an occupational health and safety management system philosophy from Z45001 and ANSI Z10. So Plan, Do, Check, Act, and it's a continuous improvement model on purpose. It's a closed circle. So if you don't have a compliant program, you won't be following a Plan, Do, Check, Act philosophy. All right, so the Plan, Do, Check, Act philosophy is really, we've got these regulatory obligations and we need to plan. And the plan is not just providing arc flash and shock training, paying for a study and buying PPE. It's more than that. You've got to step back from this topic and dig through these standards. And most companies aren't, because they're getting bad advice, or they're being incented that if you have training and studies and PPE, you're compliant, and you're not. You're actually exposed to oversight from the OH&S regulator because you've got some nuts and bolts, but you don't have them, screwed down tight, and you have no information to back that up, right? So you've got to understand those regulations, but you got to dig deep through the standards that apply. And ultimately, an occupational health and safety management system, you'll have one of those, and that should actually be the starting point. Well, why do we have that safety management system and don't have any documentation for electrical safety or an electrical safety program? So I find that that's strange, but again, companies will have an occupational health and safety management system, and it's most likely compliant, but then they won't have appropriate electrical safety documentation and they won't have an electrical safety program. So get organized, get information, strike a project to develop a compliant electrical safety program, constitute an electrical safety committee, do some gap analysis work, right? Understand what that documentation should include, right? And then implement it. Once you implement it, you got to audit it. Well, in real time, we want to monitor and measure performance. And that's another aspect of the required risk assessment procedure that's documented in 70E and in Z462, but also an occupational health and safety management system. So we've implemented those controls. Are they working in real time today, this week, this month? And then audit that program annually, right? Or have an external electrical safety audit completed on your electrical safety program every 3 years. But internally, you should be auditing it, and you need supervisory level audit on a day-to-day basis. All right, so incident investigation analysis, your program needs to include incident reporting and investigation and emergency response requirements, right? So again, you've got to have a compliant framework of that program and have all the nuts and bolts there. But this Plan, Do, Check, Act philosophy it's amazing, because this is really the starting point. We need a program. Why? Because it's the best due diligence that we can have, and it's a mandatory requirement of 70 and Z462. How do we do that? Well, again, that's applying, again, a project management type approach and looking to the standards and support to get that framework and table of contents, but then you got to audit it and act on any corrective actions. Act on the findings, implement corrective actions, and every 3 years 70E and Z462 is updated. So your electrical safety program ultimately needs to be audited at least every 3 years against the changes in 70E and Z462. So here's some common gaps that I find. The framework of your program is not consistent with occupational health and safety management system standards. It doesn't identify principles, controls, and procedures, doesn't adequately identify roles and responsibilities. It doesn't include a qualitative risk assessment procedure that the employer has completed, and then field process used by the worker to identify hazards, assess risks, and implement the expected hierarchy of risk control methods. So I find that there's a huge gap, that there's no formal risk assessment procedure in a program. There's hazard identification, and we sent the worker on training. We bought them PPE. They're supposed to apply the training and select the PPE, and we got these labels from the study, right? But that's not a valid outcome of a risk assessment. Those are controls, but you have no formal evaluation if they're appropriate risk controls. The electrical safety program, as identified in 70E and Z462, needs to include a detailed risk assessment procedure. Also, you're missing field level documentation and tools. An energized electrical job safety planning form is not being completed by the qualified person before they complete energized electrical work tasks. There's no audits. The electrical safety program, supervisory level, including field level work or external audits. There's myths and misinformation about arc flash, and they're not managed. Electric shock is neglected, which I sort of outlined with the electric shock sequelae at the beginning of the webinar. The employer believes that arc flash and shock training is the primary solution. Lets the trainer dictate the policy. Training is not field applied after the training is provided as no ESP. So this is, in my opinion, this is high risk, that if you've sent your workers on training and the person at the front is not a subject matter expert on 70E or Z462, and there's a lot of storytelling rather than basically telling the student, what they need to learn and apply from 70E, that you're going to have problems, right? You could have workers refusing to do work because they've been told that they're going to get killed from arc blast pressure, which isn't true, right? And then ultimately, I find that the training is not applied. When I come onto a client site to do an external electrical safety audit, we've provided training. I see no evidence of being applied because there's no electrical safety program. The employer purchased arc flash and shock PP with no specification. The arc flash PP's evolved, and there's so many vendors feeding into that market now that you got to be very careful on what you buy. The cheapest solution isn't the best solution and isn't a compliant arc flash PP solution. Shock PP is simple. It's the arc flash PP that's evolved quite a bit. So buyer beware. The employer's incented that they need an arc flash and synergy analysis study, or they're not compliant. That's also a false statement, but there is so many companies feeding into that portion of this discussion. Major equipment manufacturers using their brand name and incenting you to get a study done because you shall get it done. You need to take control of that, whether it's a major electrical equipment manufacturer or a major engineering consulting firm, or even down to a small consulting firm. You need to control these studies, and you do that with a scope of work and technical specification, but I find that you don't have one. So there's no control. It's like a blank check, right? And you don't have any control of the quality and the outcome of that report and or the installed labels. There's so many non-compliant labels out there, it's never going to get fixed. So in your electrical safety program, using, again, a defined risk assessment procedure, we can bring clarity, right? We can answer these questions formally, and we can ensure that we have appropriate due diligence, the employer does, because you can defend it through the documentation in your electrical safety program, right? Rubber insulating gloves, leather protectors are required when? Arc flash PP is required when? We need an energized electric work permit because the energized electric work permit in 70 and Z462 is also completely mismanaged, completely miscommunicated, and misunderstood, right? I don't want any repair alteration work completed energized, but your electrical safety program needs to define an energized electrical work permit process policy. And then you control that discussion, right? So this electrical safety program is compliant will answer all of these questions through the program, right? Through the program. We apply the training against the program, but the program is the document, the electrical safety program. This work task could cause a secondary burn because that's actually a myth. I'm safe to perform this work. So some of the myths and misinformation are inhibiting work being completed that we need to be completed. So compliant electrical safety program will provide tools to more effectively manage human performance and the likelihood of human error causing the exposure to electric shock or creating the abnormal arcing fault when the qualified person interacts with the electrical equipment. So workers' ability to manage factors that may interfere with the effectiveness of risk controls, right? So workplace culture, mental health issues and concerns, distractions, information overload, training and competency, errors, mistakes and lapses, complacency, time pressure, and violations. So through the electrical safety program, we want to drive down the likelihood that any of these would lead to a higher probability of the worker being exposed to electric shock and to interacting and making a mistake that causes an abnormal arcing fault and an arc flash to occur. 70 and Z462 have evolved substantially. Way back in the 2004 edition of 70E, it included the requirements for an electrical safety program way back then, but the content was not that much. The content requirements for an electrical safety program have increased in 70E and in Z462 to the latest editions. The other thing that changed is in the 2015 editions, they became 100% risk assessment based standards. This is a game changer, and it was the right decision. It aligns with occupational health and safety management systems, but I find again that a lot of the arc flash and shock training does not discuss the risk assessment procedure. They only focus on the two unique risk assessments in 70 and Z462, the shock risk assessment and the arc flash risk assessment. But the employer needs an overarching job-based risk assessment procedure, and underneath it, the expectation is to define additional protective measures. The qualified person will complete a shock risk assessment and an arc flash risk assessment. So the game change that occurred is there's a lot more detail here that you need to be aware of, specific to the requirement for an electrical safety program. And one of those things is the electrical safety program needs to include a defined, completed, documented risk assessment procedure. So embedded in 70E, Article 110.5 says the employer shall have a mandatory electrical safety program. It provides some guidance on content, and it will point to ANSI Z10 for additional information on how to build an occupational health and safety management system. In Z462, we have the same content. We're technically harmonized on most of the standard content. So in clause 417, it says the same thing. An employer shall have an electrical safety program and provides that same generic content. But what's different in Z462 is we reference now ISO 45001 as CSA Z45001. And if you dig a little deeper, right, into Z462, we have a complete annex that cross-references how you can use Z462 to fulfill the requirements of building an occupational health and safety management system, AKA electrical safety program. You won't have this annex in 70E. This is where we diverge quite a bit between Z462 and 70E, is the annexes are, although there's a lot more of them in Z462 than there are in 70E. As well, 70E has several annexes we don't have in Z462. Ultimately, I'd recommend that you have a copy of Z462 and 70E as your toolboxes related to your electrical safety program. So the definition of an electrical safety program, and even this is where I think people maybe don't even read the definitions that are in 70 or Z462, but it's a documented system. So it's more than one document. It's multiple documents, a main document, appendices, forms, flowcharts, infographics, checklists, right, procedures, right, and those documents direct activity appropriate for the risk associated with electrical hazards. So it's multiple documents working together as a system. It's just not one document. So as far as guidance from OSHA, a lot of people don't and aren't aware of this, but OSHA provides recommended practice for safety and health programs. You can download it from that website, and it provides guidance on what I'll call a very simple framework or table of contents for an occupational health and safety management system or an electrical safety program, right? So this is a great document. It's got some great information, and it provides more detail on these 7 elements, right? So management, leadership, purpose, principles, and scope, worker participation, hazard identification and assessment, hazard prevention and control, education and training, program evaluation and improvement, audit, and communication coordination for host employers, contractors, and staffing agencies. So there's another one too that I find that employers have employees, but they bring contractors on their site, and they need to pay attention, and your electrical safety program should have a contractor management section as well. And we should have oversight and auditing of that contractor by the host. right? So this guideline's online. That's the link where you can download it. And it actually has this image in it. And it's, so why? What are the benefits? Well, OSHA says, implementing a safety and health program can help employers avoid the indirect costs that result from workplace incidents, such as time lost, right? Replacing injured workers and loss or damage to material, machine, or property. The key is you injured a worker first. So that is the first priority. You've injured a worker, or heaven forbid, there's a fatality. But then there's these indirect costs, right? And so they're saying if you implement an occupational health and safety management system, it should help improve your likelihood, meaning driving it down with respect to having, in this case, an electrical incident resulting in injury or heaven forbid a fatality. So really good document, download it, check it out. Now in Canada, we have provincial guidelines and we have what's called a certificate of recognition program. And what happens is the government here has advised employers that if you develop an occupational health and safety management system, get it audited, and it passes a certain score, that they'll give you insurance premium rebates. So I've just listed Ontario through the Infrastructure Health and Safety Association, a link to where they have information on the framework of a safety management system, as well as Alberta, my home province. Alberta Workplace Health and Safety also has again, core, but the governments will provide different recommendations. So for Alberta, from Workplace Health and Safety, it has an entire document and it has 8 elements in it, right? 8 elements of a safety management system. So you don't have to worry about the core. What you want to look at is what they're advising you you should have included in your safety management system that then would be audited and then checked and again scored, and then you have a compliant occupational health and safety management system or electrical safety program. As far as Ontario in Eastern Canada, the Infrastructure Health and Safety Association, again, it lists these, I think there's 16, 2, 4, 6, 8, 10, 12, 14, 16, 18, almost 19 different elements. So these are elements. They aren't necessarily in the right order of how you have this content developed in your quote occupational health and safety management system, but this is what the government would be looking for, right? So your electrical safety program should have content that satisfies these framework or table of contents requirements, right? And that's in Ontario, Canada. Now, why prioritize the electrical safety program? Save lives. You want your team, stakeholders, and property truly protected. It's the right thing to do. So if you don't have a program, I'm telling you, it's the right thing to do. It will validate the training. It will validate the PP or allow you to, realize that you don't have the right PP. And it will also put you in control of these arc flash hazard incident analysis studies that you've been, again, incented to pay a lot of money for with no scope of work tech spec and then non-compliant labels installed that aren't going to help you and or the qualified person when they're trying to get the information they need to apply to their arc flash and shock risk assessments. When people feel safe, they're more productive, right? When productivity increases, you create scalable efficiencies. Heaven forbid that this is the case, but your organization has experienced an incident and you want to ensure you're doing all you can to prevent future occurrences and the human impact, financial loss, and brand burdens that often accompany the incident. That OSHA infographic that I just showed you. You'll realize financial benefits of low workers' compensation insurance premiums, also lower costs related to implementing the risk controls. There's a lot of money that's been spent on arc flash specifically, where I don't think the employer can gauge, that they spend the right amount of money. Right? It's almost like I said, been a blank check specifically for the studies with no scope of work and tech spec. Reduce your regulatory risk. So this is the lowest priority piece. We want to save lives over here on the left first, right? That's been my goal since the beginning. But I've also quoted since the beginning of my electrical safety consultancy, we got to get it right. And again, we can use a compliant program and audit it to make sure we are getting it right and that ultimately the controls that you are selecting and applying are adding the value that we need to the worker when they do authorized energized electrical work tasks. So compliant electrical safety program ensures all aspects are managed. Defendable compliant documentation system. Work task-based qualitative risk assessment will be used to validate the controls that you've selected. The incident analysis studies use a scope, work, and technical spec to ensure you get a quality report and that there's content in the report that you control. You don't want any information in that report about OSHA regulations and exasperating on about hazards and risk assessment. That's not part of the scope. It's an IEEE 1584 study, and it should be technical reported information only. I find too much information embedded in these reports that exposes the employer to liability and is out of the scope of work of IEEE 1584 and IEEE 1584.1. By the way, IEEE 1584.1 just published its 2022 edition, and it does explicitly clarify what shouldn't be in the report. Again, better management of training, communication, and engagement of your employees, and then you will have arc flash and shock PP tools and equipment that's what I'll call compliant as well, right? There's a lot of arc flash PP out there that's cheap, but it isn't compliant. It has performance issues. So the cheapest solution isn't the most effective solution or the best for the worker. And arc flash and shock PP has evolved substantially, right? So the improvements in arc flash PP actually help drive down leg of occurrence. They're protective, but they actually benefit driving down leg of occurrence. So project execution plan, phase 1, phase 2, phase 3, phase 4. Treat developing an electrical safety program like a project, right? So get organized, kick it off, get a project manager, constitute an electrical safety committee, right? Kick off formal meetings, gap analysis, review documentation, customize, prepare final documentation, draft for management approval, right? After the program's approved, roll it out, but provide electrical safety program rollout orientation training. This is the actual training that workers really need, is they really need training on what your requirements are, what your policies are, what your practices are, and what generic procedural requirements you will have the worker follow, right? Applying the generic NFPA 70E or Z462 training. And then phase 4, you've got to maintain your program every 3 years at least, and have internal audits where you might update your program, or external electrical safety audits. The Plan, Do, Check, Act philosophy is behind this 4-phase project execution plan for developing and implementing an electrical safety program. So define project, have a project execution plan and a documented process, assign a project manager, set a schedule. So that you can't develop an electrical safety program in a day, a week, a month. It's going to take 3 to 6 months, because you need time to work with a defined constituted electrical safety committee to review everything that you've done so far, educate everybody, and get rid of the misinformation, right? So you're gonna have to get rid of a lot of misinformation by getting everybody on the same page. Again, there's a lot of bad information out there specific to arc flash, right? From training, from websites, from marketing materials, from companies that are trying to sell training and studies. So you got to manage that, and you're gonna have to work that within your electrical safety committee. Do a gap analysis, audit, right? What have we done so far? And then you have to obviously gap analysis against understanding, and that's the problem, correctly understanding the standards. So you may think that you've got compliance, but you're not, you're not understanding the standards or the PP requirements correctly. Formal meetings with minutes and action items, methodical review, management approval, and then implementation of your program and rollout training, and then you move into the maintenance aspect, right, in the 4 project phases that I illustrated. So review and manage the risk control methods implemented to date. Ensure the arc flash and shock training you provide is compliant. Ensure the arc flash and shock PP that you have procured is compliant, and budget for upgrades. Arc flash PP evolution not only protects, but reduces leg of occurrence now. The true color gray lens technology, right? Escape strap, right? The improvements are phenomenal. The actual layering of thinner layers of fabric to achieve a higher arc rating makes it more comfortable for the worker to wear. Ensure that your arc flash and shock, that your arc flash hazard and synergy analysis studies are compliant and the labels are compliant. I'll show you some compliant labels coming up and some non-compliant labels. Ensure you audit and follow the Plan, Do, Check, Act occupational health and safety management system cycle. So electrical safety program framework or table of contents, right? So we've got the standards that I've identified briefly, right? We've got some guidelines from the regulators, right? So the standards, guidance from the regulators. Again, we've got 70E and Z462. Again, there's a lot of information that if you weren't aware of it until today, now you are. So these are tools that you can use to develop a program or to audit your program, right? And what I help companies do is interpret these standards, right? And develop compliant electrical safety programs and audit them, right? Against interpreting standards, and again, trying to manage potentially all the misinformation that's unfortunately been injected into your company from other sources. All right, so checklist of key requirements. This is just the start of a checklist, but 70E and Z462 give us some really good guidance on what our electrical safety program should cover. And there's actually a development implementation checklist that you could use as a tool, again, as part of your gap analysis on, well, we don't have a program, what do we need in it, right? Or we have a program and what should it include, right? But like I said, 70E and Z462 in their 2021 editions in Article 110 and in Article Clause 4.1 really provided a lot of clarity on the information flow and the content that at a high level your electrical safety program should include. So in Annex F of 70 and Z462, as far as the risk assessment procedure, which I implied earlier that a lot of companies haven't implemented, and that's from experience. That's from when I arrive on the site, right, and to an external electrical safety audit, and where's your program, and have you completed a formal risk assessment procedure as the employer to, again, proactively step back from all of it, and based on work tasks that your workers would perform, energized, have you completed a qualitative risk assessment? And this flow chart's in Annex F, and it's a great flow chart. Establish the context, and then complete the risk assessment, 3 steps. Hazard identification against work tasks, analyze the potential severity of injury or damage to health and the life occurrence, and then evaluate the hierarchy of risk controls on the right that you need to apply. This is done in an office environment. But then ultimately in the field, we want those risk controls to be field applied. And at this point, the supervisor has to monitor and review those controls. There's another gap, the supervisor's role in all of this. What do you mean it's my responsibility as a supervisor? Any workplace hazard, the workers that report to you, you have sort of the key responsibility to ensure that you, as the employer's representative and supervisor, that you're involved with those workers, identifying all the hazards they're exposed to, and then specifically arc flash and shock, and making sure that the hierarchy of risk controls that we want to apply as the employer to achieve an acceptable residual risk level, which is as low as reasonably practical, is actually true, right? So you want to monitor and review the controls in the field. This is a great flow chart. It's simple, but even this has not been referred to by employers in Annex F. And your electrical safety program includes a formal qualitative risk assessment procedure. It should have an electrical hazard risk assessment matrix and a work task-based risk register table. And what we're doing is trying to validate these controls, the ones that as an employer we can implement. Substitution and engineering safety by design, that's a whole separate topic. I can't talk about that much, but our priority is to eliminate. If we can't eliminate, then the worker can apply warning signs and barricading, the training that they've received, procedures that they've been given or provided or that they write, and the PPE. So ultimately we're down here with the controls 4, 5, and 6 are ultimately the workers' controls that they can apply, but the employer has to define what those controls are, and you do that through a compliant electrical safety program. Elimination or ALARP is our goal. Managing these arc flash hazard incident analysis studies and a report issued. So again, arc flash incident analysis calculations, IEEE 1584. It first published in 2002, new formulas in 2018, but unfortunately, I'm still seeing reports come out where the labels include a hazard risk category number, a category number, a level letter, and they shouldn't. And because there's no correlation between incident energy analysis and the arc flash PP category method and an arc flash PP category, right? So in an attempt, both the Z462 Tech Committee and 70 Tech Committee, due to public comment, included new tables that doesn't imply that it advises the employer that when you have incident energy analysis, you stipulate arc flash PP with an arc thermal performance value of 1.2 to 12 calories every day task wear, or an arc flash shoot with an ATP greater than 12. And I just noted here on the bottom right that the 1584.1 guideline that not many people know about that you could actually use and reference, and I have, to develop a scope work and tech spec. That's how you can do a better job of controlling these studies to the engineering consultant. It's important as the employer you take control. They don't control, but unfortunately they have been. You take control and hold them accountable for what they're offering in their report, for detailed content and review of again, how they've established the parameters for the calculations, and that you're involved in the decisions, right, that they may make on your behalf, and in turn, a compliant label. So this 1584.1 just published August, it's brand new, great reference. And again, the scope work technical specification, I've taken information from this document and developed a detailed scope work and tech spec, because there's again more to the standard. You just can't, you can't just say in your RFP, you must comply with IEEE 1584.1. And if you at least say that, that'll be better than just saying, give me an arc flash study, because you can audit the consultant against 1584.1. But what I recommend is that you have your own company arc flash incident energy analysis study and report, and it'll have additional information for pre-qualification of the consultant, a lot more detail there, and then following the procedural steps in 1584.1, and then actually offering a compliant label. These are compliant arc flash and shock labels that meet ANSI Z535. In Z462, we have Annex Q, which isn't in 70E, and Annex Q defines a compliant label as well. Notices. So you can also have notice signage, and this is a cool notice signage that again came up in a recent external electrical safety audit that I'm doing an electrical equipment inspection with the journey person electrician, and he goes, well, we have these maintenance mode switches. I said, oh, are they active? Are they programmed? And he said, well, yeah. And again, the labels on these switches are tiny. And I said, well, you know, are other workers aware? And you know, so because it was new equipment, and so I said you should install this larger notice sign, right? This low voltage switchgear includes maintenance mode switches on feeder power circuit breakers, and provide some procedural instructions. And this would be basically an 8.5 by 11 sign, so it stands off, right? And you put it on the back, the front, and the sides of the switchgear as additional, again, notice. The hierarchy of risk controls said warning signs, right, and barricading, right? We need the worker to have more awareness that the outcome of the study was the installation of a maintenance mode switch to reduce incident energy on the electrical equipment that's being fed by the feeder power circuit breaker, right? So there's a lack of signage, a lack of clarity on power distribution equipment when I provide external electrical safety audits. These are non-compliant labels, by the way. All right, so danger signal pan and the incident energy is 0.9 calories, right? That is not the appropriate signal pan. Warning signal pan is appropriate, but it's got PP category level 0. I don't even know what that is. And it's 0.10 calories per centimeter squared. It's insane. And then the danger label on the right. I see this too often. No safe PP exists. Energized work prohibited. Well, the label should not dictate policy. The electrical safety program should dictate policy. And it says PP category dangerous. Well, there is no dangerous PP category anywhere that I'm aware of in 70 years Z462, and it's only 47.8 calories per centimeter squared. And the reason that this label is printed out is because the consultant is unaware of the fact that arc blast pressure does not correlate with incident energy whatsoever. So this is a systemic problem for the last 10 years of these studies, and there's a lot of these danger labels out there. No PP exists, and a cutoff at 40 cals. The employer has been completely misinformed by the consultant doing the study that incident energy at 40 cals or greater will be a high arc blast pressure. It's completely wrong. So again, within your electrical scope of work for these studies, you need to take control of parameter selection. You stipulate the parameter selection, the consultant then validates why they would agree or disagree with you on the parameter selection. The box electrode configuration selection, you again take control, and the consultants has to advise you why they would select a very conservative HCB, horizontal conductor box electrode configuration. And ultimately, you tell them what the box electrode configuration is, and then they justify why they would select a different box electrode configuration. This scope of work and technical spec is part of your electrical safety program, your document system, right? So again, some guidance there. And here's the 40 cal myth that I'm talking about. And again, this 10 years of this misinformation and reports, and the consultant didn't substantiate it. It's really quite unfortunate, right, that there hasn't been any accountability to this. When I do get involved with clients, I do hold the consultant accountable if they have this information still. But Dr. Ralph Lee, PhD electrical engineer in Edmonton, Alberta, he was one of the pioneers in coming up with formulas for incident energy and the arc flash boundary, and some of his initial work on arc blast pressure. So arc blast pressure doesn't correlate to incident energy. It correlates to abnormal arcing fault, which makes complete sense to me. And this information is actually documented in the IEEE Yellow Book, or now the IEEE 3007.series document. Arc blast pressure correlates to abnormal arcing fault, not incident energy. There is no 40 cal myth, right? Technically, the label danger should be at 140.1 calories because we don't have any arc flash PP available with an ATB greater than 140. There is 140 cal arc flash chute available in the market, and it can be applied. So arc flash PP evolution, the true color gray lens technology, that's a picture taken through the lens of the light green tint, which is the tint that was, again, evolved from a darker brown to a dark green to a light green for infrared, filtering for your eyes. And you can see the difference. So I find that there's still true color gray lens technology out there because the employer hasn't budgeted money to buy the new PPE. So a compliant electrical safety program will have an annual budget for upgrading and changing your PPE, an annual budget for training, an annual budget for your for your employees to do internal electrical safety audit work. And you should budget for an external electrical safety audit as well. So this escape strap option, this is a brand new option brought out by Oberon Company. It's patented, and they've now got it embedded on their arc flash suit jackets and an arc flash suit vest, right? So this to me is amazing evolution for emergency release of a worker that may have been shocked or been exposed to an arc flash. And again, if you do have two workers, the electrical safety watch can be holding the escape strap. If you're by yourself, you can have the escape strap on the ground behind you, just have to manage it as far as potential trip hazard, but it's there behind you. And if you do have an incident, someone could come and use that to do emergency release or move you away from the electrical equipment. So more evolution again. Now this is a video of that escape strap being used. So no rescue hot stick. Unfortunately, that's what was available and it's been procured, but you can completely abandon the rescue hot sticks now and move to this escape strap. Now arc flash PP works. Again, I've been lucky to get on site, and this was via Bulwark at the Chemo Lab. So just a quick review of arc flash PP. If you're wearing it, it will work, right? Again, this is what it'll look like on the right. It will carbonize. And again, arc flash plasma doesn't bend around you. So you can see that the garment wasn't damaged at all. It waves across you plainly and then will break, right? So the next video, it is a traumatic event. I don't want any worker exposed to arc flash, but we need to get arc flash PP on workers that are exposed, and it will perform. It will perform.
3, 2, 1.
So that's probably a 10 cal arc flash, probably 8 to 10 cal clothing. And the key was that the arc flash plasma doesn't bend around the worker. It's going to be a frontal exposure. It's going to carbonize the clothing. It's going to melt and or carbonize the lens. But underneath it, this is Scott Majarno with Tyndale. The reason we need non-meltable fabric worn underneath is it will melt. So they surprised us because underneath the shirt, right, they had a polyester shirt and it melted. This is Derek Stang over here on the right, on the left-hand side. He's with Bulwark, and I was really glad to present at the Bulwark University that year and attend these arc flash at the Chemo Lab. So arc flash PP will work. Separately, I've been able to get to the Kinectrics lab in Mississauga with Oberon Company, and this is their two color gray lens shield with an LED lamp, and we arc flashed it. It's a 17 ATV shield, arc flash about 20, and that's what you'll see is this carbonization and melting, but the LED was still on. All right, the LED was still on. So this is the actual arc flash of that shield. Right, so that's a typical arc flash. It'll be very fast, right? The electrical protect device will open quickly and a branch circuit application. So lots of information. I'm running probably over a little bit, but I'm going to stay on and finish. So hopefully you'll stay on as well. As Nick alluded to, this is recorded, so it will be made available to everyone. So by developing, implementing, and auditing an electrical safety program, ensuring it is compliant, you will save lives. You will reduce risk to as low as reasonably practical, and you'll be able to prove it as the employer. That's the problem, is no one's testing their due diligence. And ultimately, I do recommend that you do have a mock exercise of an electrical incident and test what you've done. Test what if you've had training, you've got studies and labels, and there's PPE, then do a mock exercise and see if any of that actually has been working properly or effectively to achieve what we'd expect, right? No injury or residual injury is reduced to as low as reasonably practical. Ensure workers who have received arc flash and shock training apply the training to personal benefit and risk reduction. So this is the reason you need a program. Without the program, the training won't be applied. The worker come back and the supervisor probably didn't even go on the training, and then the worker goes, well, what do we do? And there's no direction. And I find that this is a systemic problem with arc flash awareness training, arc flash training, where shock's not even the title of the training, and it's storytelling and videos rather than saying this is how to use 70E. and this is how to apply it in the field, right? And make the right choices, right? So again, we can make sure that the controls that you have been applying will add the benefit that you want. Ensure confidence and certainty with your workers that will lead to increased productivity. Get rid of the myths and misinformation, the scare tactics and training, the fear, and that shouldn't be part of the training. The training should be, what are you going to do personally to control this topic, to control exposure? What are you going to do? Here's the tools I'm going to give you and the information that you need to arm yourself with, and then some documentation tools that you'll need to fill out, right, before you do energized electrical work. That'll help you slow down, document your arc flash and shock risk assessments, and then the worker selects the controls that they'll apply that you've provided them. Stronger electrical safety culture and positive proactive behaviors. The electrical safety program will deliver that, right? It puts more formality around, again, the training, the PP you've purchased, the studies, and the labels. Consistency across your company. So I find large enterprise organizations that I work with multiple facilities, they've all diverged, right? This program will bring everybody back to the same place. Like, divergence is not good due diligence. It's actually liability. All impacted workers will be addressed. So non-electrical workers at your place of employment need to also be addressed by the electrical safety program. Portable cord and plug connected electrical equipment extension cords, and the need for GFCIs for all workers, but specifically non-electrical workers. Forward realistic budgeting and cost control. There's been a lack of that because it's been sort of reactive. Send the workers on training, buy PP, get studies, install labels, and you have no idea, what money you should have budgeted. The electrical safety program will pull back from that and get you more organized on planning your training, scheduling your training, controlling the studies with a scope of work tech spec, right? And also budgeting for PP. So you need annual budgets, right, in place. The arc flash PP's evolved in the last 5 years, the true color gray lens technology, the escape strap. There's other elements of PP that I didn't even include, like these probe extenders from Fluke. These reduce risk of a worker getting shot because the hands get further out of the box. You'd still need rubber insulating gloves because Fluke didn't put the guard here, right? But I can see the work better, and my hands aren't going to be in the box and potentially remove a wire, right? So most companies don't know that these probe extenders exist, right? So when you do a formal program, you're going to do more homework and research and dig deeper into the PP side of things, right? Or get some advice by someone like me that's researched this information and says, well, there's even a proving unit for your high voltage proximity detector from Salisbury that you maybe didn't know about. So you can have a portable proving unit, both for for high voltage and for low voltage. Fluke's proving unit for your low voltage test instruments, right? So don't risk negative impact to the operation facility. So incidents, and if they're fatalities, will have a significant negative impact, and that'll affect everybody on that job site. So the electrical safety program will help limit the likelihood of damage to electrical equipment downtime and lost revenue and repair costs, because we're going to better control the likelihood of having an abnormal arcing fault. If the likelihood of having an abnormal arcing fault is driven down to as low as reasonably practical, there's no arc flashes, right? Again, an abnormal arcing faults haven't been occurring at a high frequency to start out with, but with a compliant electrical safety program, again, with some of the information I presented today, the likelihood of an abnormal arcing fault will be driven down to as low as reasonably practical. Control the technical quality and lowering costs of your arc flash interaction analysis studies. The program controls the label, and then you have a scope work and tech spec as part of your electrical safety program that controls the consultant, holds them accountable. They don't have a lot of extras because you're telling them exactly what you want explicitly, and you can hold them accountable for it. And make sure the reports only include technical information. You don't want any background on OSHA and hazard identification and risk assessment. It's not relevant. It's out of their scope. Ensure compliant arc flash and shock labels are installed through your electrical safety program, controlling the spec of the label that I showed you. And ultimately, then you're going to be able to prove that you have compliance to regulatory requirements and no legal costs related to electrical incidents, right? So remember, the highest priority is to save lives, no worker injuries, but ultimately the rest of this is also delivered by the employer for their company, right, with a compliant electrical safety program. So you need to ensure the framework and table of contents includes all required content aligned with occupational health and safety management system standards. NFPA 70 and Z462 provide guidance and provide the tools needed. You need to audit what you have and put into place to date, right? So at this point, Nick, I'll defer to questions. We're a few minutes over, but I'm going to keep going, and I'm hoping that we've had people that were able to stay on. So Nick, if there's some questions.
Yes. And if you guys have any questions, go ahead and feel free to submit those now. We have a couple here that have been submitted throughout. So will you define what auditing is? Is there an audit of the written program, and is there an audit for people following the program?
So the audit, in occupational health and safety auditing, there's three things you do to validate and verify that what you expect to be happening is actually happening. And it's a review of the documentation. It's observations of workers. If you can do observations of energized electrical work tasks being executed, right? That would be very good due diligence, because then you're actually, confirming the workers doing what the electrical safety program advises them to do when they implement and follow through on completing energized electrical work. And then you want to do inspections of the electrical equipment, right? So validation verification techniques are documentation review, observations, plus interviews or discussions. Group discussions I find are valuable, but one-on-one interviews that are confidential, right? Again, and when you write the report as the auditor, you don't use anybody's names, obviously. You're generically presenting information from, again, review of documentation, observations, interviews, and electrical inspections. And then you're identifying, again, findings and recommending corrective actions. But you're auditing the program itself. So if your program's not compliant, then you're going to be auditing, in gaps. But if you don't understand what those gaps are, then you may feel that you have a compliant program, which some people answered yes, without having more in-depth information on what you really need to have included in that program, but the field application content, so that we know that the residual risk level we expect is true, right? So you're checking that the training is being applied, that the workers understand. And I ask a simple question: what does ATPV stand for? And they've had training, and the qualified persons don't even know what that is, because they haven't been applying the training. So training without application will not lead to competency, which is another topic. Electrical safety competency is lacking in industry because there's no electrical safety programs for the training to be applied against, and your auditing will prove that. Nick?
Next question is, can you please elaborate on the addition of CSA Category 5, 70 limit of Category 4, and the correlation between blast and incident energy?
All right, so that's an interesting one. We are having some technical divergence now between CSA Z462 and NFPA 70E. So the review processes for 70E and Z462 are quite a bit different. 70E through NFPA is a lot more formal. With CSA, it's a lot less formal. So IEEE 1584 2018 edition, published November 2018. Well, that was way past the NFPA 70 public comments for the 2021 edition. But in CSA's world, the Z462 Tech Committee, we could take that new standard and review it. And so we did. And what we did is, some of the electrical engineers that do studies on our tech committee, they revalidated using the formulas, the anticipated incident energy using the arc flash PP category table method. And conservative parameter selection was used. I'll go with that for the table method. And for the low voltage switchgear row, using the new IEEE 1584 formulas, again with conservative parameter selection, we achieved 73 calories. So we created a new arc flash PP category 5 with a minimum 75 calories per centimeter squared arc thermal performance value arc flash suit requirement. So 70E, their tech committee didn't have time to review that. And in the 2024 edition of 70E, they did not review it and did not update and include an arc flash PP category 5 in the arc flash PP category method in 70E. So it is a significant technical divergence in my opinion. But again, if you have incident energy analysis studies completed, right, that would be the first option to giving information to your qualified persons to determine additional protective measures. But if you don't, then for low voltage switchgear, Z462 recommends minimum 75 calories per centimeter squared ATP arc flash suit, which is a divergence from 70E.
Okay.
Nick?
And how do I find a third-party audit firm in my area?
I'll tell you what, I'll come and do an external electrical safety audit anywhere in the world, right? So give Nick and Grace a call, and I'll go anywhere, right? So I have been in the U.S. recently. I've been in the U.S. doing actual, ESP rollout orientation training. So it's, again, this is what I do. I help companies figure this out. So if you need an external electrical safety audit, sign me up.
Awesome. Typically, workers are overwhelmed with work documents to which they may tend to provide incorrect information or pencil whipping.
Right.
The document as a tool are not used appropriately. It seems that OSHMS and NFPA 70E documentation overlaps. The electrical job safety plan should complement the risk assessment documentation for electrical hazards. How are these being handled in other industries?
So in my experience, which I came from the oil and gas industry, I'm telling you, occupational health and safety was on the roof, right? We had to have a safe work permit before we could even go in the gate, and all hazards had to be identified. We had to have a hot work permit, a cold work permit. I added the energized electrical work permit to that requirement. And then, I have to pull back from that when I talk to other industries, because their occupational health and safety management systems aren't as, I guess, heavy on field-based documentation. So within occupational health and safety management system standards, it's quite consistent that you have some form of field level hazard assessment, right? It could be called a task card, a start card, a pre-task work card. I'm more familiar with FLHA, field level hazard assessment. So that's an all hazards document that the worker has to stop and fill out before they do a job, all hazards. Within that FLHA, it should say arc flash and shock. And then as per 70E and Z462, the qualified person has to document an energized electrical job safety plan, and there needs to be a separate form for that. So in safety, there's 3 key words: document, document, document. And you have to work with your qualified persons. Again, that might be a challenge, but we've got to change the culture and behavior that they have to fill out documentation before they do energized electrical work. It's going to slow them down. They're going to be concerned about productivity maybe, or, well, you have to temper how long it is required to fill out an energized electrical job safety planning form. This is an example of one, right? It's a little card version of it. It can be 8.5 by 11, but they have to stop. And after they fill out, your standard field level hazard assessment, if you have one, then they would fill out this second document. The energized electrical work permit should never be used, really, so we don't have to worry about that. But if it is used, well, then there will be a lot more delay in planning and discussions involved, so that's a separate topic. But this job safety planning form that 70 and Z462 require, we need to work, the supervisor needs to work with the employee and get them to realize that it takes 5 minutes, and the whole pencil whipping has to be managed by the supervisor. We have to demonstrate the value to the worker for them to stop and slow down and plan their job, to go through this and say, I'm exposed and here's the controls that I'm going to apply, right? And I'm verifying those controls, and I'm also verifying that I've pre-use inspect and checked my arc flash and shock PP tools and equipment, right? So that document proves that when we give them this PPE, that we allow them time, right? So there's the other thing, we need to budget more time, not a lot more time, but we need to budget more time for maintenance work tasks to be executed, right? It's an evolution of a change in the way that this worker's been incented to just go out there, get it done, solve the problem, and get the next job, right? So you've got to work at the documentation. It's important. And I find that there is no documentation. There is no energized electrical job safety planning form being filled out when I do external electrical safety audits. So, the employer does not have a compliant electrical safety program because it needs this documentation when we look at occupational health and safety management system standards and 70E and Z462's requirements specifically underneath that.
Excellent. So can you briefly discuss incident energy versus blast potential and their overlap or lack thereof?
Yeah, so I mentioned that the myth, what I've called it the 40 cal myth for over a decade, but I'm one voice, and that's the challenge. There's other voices that agree with me, but we're overshadowed by an army of consultants doing studies that haven't educated themselves. So I'm a professional engineer, and I'm criticizing my profession quite openly, and I will continue to do that. So and training, people that have been doing training aren't subject matter experts, haven't dug into this, and are miscommunicating it as well. Dr. Ralph Lee, right, his original research which is documented in this IEEE Yellow Book, now the 3007 series, way back then, right, his graph was included. And it says that blast pressure correlates to abnormal arcing fault. It has nothing to do with incident energy. So 40 calories per centimeter squared was miscommunicated in 70E and Z460 because there was a little note that said at greater than 40 calories, greater emphasis is required. That was a tech committee error as well, but they voted on it based on the information they had at the time, and it was removed when additional information was presented that said, hey, that was wrong, right? So incident energy doesn't correlate to arc blast pressure whatsoever. It never has. Dr. Ralph Lee's research from the late 1980s validated that, and I've been using that graph for over a decade, right? So arc blast pressure for standard low voltage and high voltage energized electrical work tasks with a lower available fault current, the pressure is going to be anticipated to be low, especially if the door is open. Now what we did is, and this is not in 70E, but in Annex K of Z462, we included this information, right, and said that arc blast pressure doesn't correlate to incident energy, and it will be much lower than it was previously indicated, especially with the electrical equipment door open, right? So we use the available information at the time, but you've got to stay on top of this. The arc flash topic is evolving. Abnormal arcing fault sustainability voltages are changing. There's more research that's coming. We still need more research on DC, right? There's more information that's just come out in the last version of 70 on capacitors. So you've got to stay abreast of this and question things that you were provided. Well, where's that coming from? Where's the substantiation for that? Why is that danger label said no PP exists? I heard there's a 100 cal suit and 140 cal suit, so PP exists. So again, this arc blast pressure has been miscommunicated since I've been involved in this topic. And I've just tried to over and over again, look at this graph from Dr. Ralph Lee. There's no correlation of incident energy to arc blast pressure.
Excellent. And Terry, do you have time for one more?
Yeah, you bet.
So a worker is tasked with voltage testing and thermography on a live ATS, and the only way to access the testing area is by removing a bolted panel. Trying to lift the panel out of the way introduces extra hazard, especially if the buswork is inches behind this panel. So is it considered live work and an energized permit needs to be filled out? Should a bolted panel ever be removed from equipment while it's live?
So through the electrical safety program that I'm advising is compliant, it would have this risk assessment procedure, would break it down by work tasks. So that job, right, of doing infrared on an ATS, well, what are the work tasks? Well, we got to remove the bolt on cover, and then we got to use the camera, right? So there's ultimately two work tasks. So within 70 and Z462, the energized electric work permit says, well, any repair or alteration, we need the permit for that. So this is an area where I advise employers to review the energized electric work permit, because how do I get to the other side to do the IR that I need to do improved maintenance, right? And predict that I might have an abnormal arcing fault through trending, right? So we want to do the IR, and that technology is reduced in cost, and there's a lot more IR occurring, but we got to get the bolt-on cover off. So the bolt-on cover may be a larger bolt-on cover. Can we remove the bolt-on cover energized? Well, yes, we can. Do we need a permit? Well, I'd say due to equipment design, how do I get to the other side to do the IR? Right now, do I have two qualified persons that I could assign to this job that can remove the bolt-on cover? If it's larger, right, or even a smaller bolt-on cover, get two workers, right? And you're driving down the likelihood of occurrence of human error, human performance, right, of the cover being pushed into the conductors on the other side. Plus these two qualified persons, they need to know that ETS. They need to know what's on the other side. There's no bus bar right there, right? Everything's on the back pan within that ETS. So there is some distance between the exposed conductors and the cover, right? So I'm trying to instill confidence in qualified persons that the tasks that they've done in the past, they still can do them today. With a compliant electrical safety program, we would have a job safety plan. We would say that in this case, we need two workers to drive down life occurrence, right? The bolt-on cover can be removed energized due to equipment design, right? And the need to do IR, right? So again, that's a quick explanation that a compliant electrical safety program would have a detailed risk assessment procedure work task based. It would identify that if we have these controls, that to remove that bolt-on cover energized would be low or moderate risk, depending on the risk matrix. And then we would either have a permit issued for that, which would say due to equipment design, we have to remove the bolt-on cover energized to get the IR on the other side. or your company could exempt the need for an energized electrical work permit for removing bolt-on covers because of equipment design. How do I test for absence on the other side of a bolt-on cover without removing the bolt-on cover? Right, so I don't want the energized electrical work permit to be a bureaucratical process. I want it to add value. So I do recommend in an electrical safety program that additional exemptions are taken for additional work tasks above and beyond the 4 that are listed in 70 and Z462 due to equipment design. So that job and those work tasks have completed energized with risk assessed and validated in the field by the workers, right, done as low or moderate risk. We need to do maintenance, and I'd recommend that we invest more money in maintenance than's being invested now. And IR is important maintenance. It's predicting, right, trending that we may have a potential for an abnormal arcing fault. So we need to make that type of maintenance, acceptable to be completed without the worker thinking that, well, I can't do that, it's not allowed, and the risk is too high, right? But with a formal compliant electrical safety program, you would have the proof that that would be done as low or moderate risk residually.
Excellent. All right. With that, we will close it out. As we mentioned at the beginning of the webinar, certificate will be emailed out immediately concluding this within an hour. We will have an on-demand version available eventually, and we will also be sending out these presentation slides to all attendees. So thank you all so much for attending. And Terry, thank you so much for your time and providing this invaluable information for everybody here. There will be an exit survey as well. If you're interested in Terry's consulting services, or if you're interested in learning about Grace's electrical safety solutions, you can take that survey and we will be in touch with you. So thanks
and
again.
We also have the brochure, Nick, that you provided. So I encourage everybody to download the brochure in the GoToWebinar control panel. And sorry, Nick, but I just wanted to make sure that I thank Nick. He's been diligent in contacting me, and Grace has allowed me to, through their support and their webinars, get information to people that I can't get access to. And I've been working with Grace. I continue to look forward working with Grace on their expert network. So download the brochure. Grace and I are here to help you. And in this case, ensure that you got a compliant electrical safety program. So thanks, Nick. Thanks, Grace.
All right. Thanks, everybody. We'll talk to you soon.